The Shellfish Sleuth. Colin Eimers is investigating why so many NC oysters die off each year and how to stop it before farmers lose entire harvests. By Maggie McIntyre. On a clear summer morning, Colin Eimers drives a boat past the seemingly endless saltwater grass that populates North Carolina's Pamlico Sound. Ahead, rows of glistening black cages bob on the water's surface in long, tidy rows. On a nearby boat, brightly colored buckets and cages overflow with oysters. A pair of workers sort the harvest by size using a large metal tumbler, rhythmically shaking the shellfish inside. This is one of North Carolina's many oyster farms, combining centuries-old coastal practices with sustainable aquaculture. Because of overfishing, habitat loss, increased cost and regulation, the state's wild capture fisheries have been in decline. Oyster farming provides a sustainable alternative, creating economic opportunities for communities hit hard by a weakened marine economy. But oyster farmers have been facing serious roadblocks. Frequent mass mortality events in late spring and early summer can wipe out up to 90% of their shellfish crop. These die-offs may be linked to shifting conditions in the estuaries where oysters are cultivated, or to biological changes that make the shellfish more vulnerable during this critical period. Colin Eimers, a PhD student at the UNC Institute of Marine Sciences, is one of the researchers trying to uncover the causes behind these mortality events and to identify what farmers and policymakers can do to mitigate the loss. His work has taken him up and down the coast, where he works closely with oyster farmers and carefully tracks the environmental conditions shaping their harvests. Brittle bivalves. Oysters are unique creatures. They are filter feeders, which means they strain small particles like algae and plankton out of the surrounding water for food. They are considered an excellent aquaculture crop because they require no sustenance, help clean the water, and can survive in fluctuating salinity and temperatures. But in North Carolina, the mortality events that Eimers studies are posing a huge threat to the industry. The big issue is that when you see mortality, it's really too late to do anything about it, he explains. What we've seen is that the pathology inside of an oyster starts weeks before the oyster actually dies. Inside an oyster's digestive system, the tiny tubules that help them process food shrink and shred. Once this happens, the oyster can't absorb nutrients properly and slowly starves. These mass die-offs have been observed in parts of North Carolina for over a decade, but they've become more widespread and severe in the last 5 to 6 years. Despite the risk of losing huge percentages of their crop in a single season, many oyster farmers remain committed. Some adapt by diversifying farm locations, adjusting their farming methods, or changing their harvest schedules. Still, the emotional and economic toll is immense. A season's worth of work can disappear in a few days, leaving farmers in financial jeopardy and threatening the vitality of small family-run operations. For a state betting on oysters as a way to revive coastal economies, the stakes are high. Continued commitment. To monitor oyster death, Eimers conducts most of his research in the field. He spends many days knee-deep in core sound, taking water samples, measuring salinity and water temperature, and monitoring oysters. And in the spring, he does bi-weekly mortality counts on various farm leases. After pulling each cage up onto the boat, he checks the oysters with a quick knock of the shell against the gunnel of his research skiff. The dead ones sound empty, making a distinct thwop sound. Eimers is continuing studies started by former IMS PhD student Mark Soselsky, now a postdoctoral researcher at the Institute, and is working collaboratively with a team of scientists to support the shellfish industry. Using years of samples, he is comparing data across times and locations to spot emerging patterns. His approach pairs data analysis with online and in-person interviews with the farmers who observe oyster health daily. Research like this brings together students, faculty, and local stakeholders to find solutions for some of the state's most pressing problems. IMS serves as a bridge between academia and local communities and houses specialized research facilities to propel cutting-edge science. Joel Faudry, director of IMS, adds that shellfish research like Eimers deepens our understanding of how North Carolina's ecosystem and economies function, and the need to protect them for future generations. Shellfish and finfish support recreational and commercial fishing sectors that contribute roughly $4 billion to the state's economy each year, and support approximately 20,000 full-time jobs along North Carolina's coast, Faudry shares. In a region without large factory, technology, or commerce centers, working waterfronts are key employment engines. Hopeful collaboration. Solving the puzzle of oyster mortality isn't a solo mission. It's a team sport involving farmers, scientists, and a multi-university alliance of researchers. A lot of what's made the work successful is the collaboration, says Eimers, who is quick to credit the oyster farmers themselves as critical partners in the research. These growers aren't just suppliers of shellfish. They're boots-on-the-ground observers with decades of hands-on experience. They are experts at watching for subtle environmental cues, like a shift in current, a slight change in oyster shell color, or altered feeding behavior. These observations guide where researchers like Eimers focus their energy, and sometimes spark entirely new lines of inquiry. Joe Harned, a fifth-generation shellfish farmer, is one of Eimers' research partners. Losing 80 to 100% of your crop is really tough to bounce back from, Harned remarks. So we've been appreciative of the research partnership because being able to see, track, and compare the data has been a big benefit for our farm and for the whole state. Eimers is also working with teams from UNC Chapel Hill, NC State University, Duke University, and UNC Wilmington. Each institution brings distinct expertise, from aquaculture engineering to marine pathology, but they share a common goal: making oyster farming more predictable and resilient. While the oyster death mystery hasn't been solved yet, Eimers hopes his team will eventually identify environmental signals of approaching mortality events, or develop farming techniques that avoid periods of peak vulnerability. This might involve changes in gear, harvesting schedules, or state-level aquaculture policy. I have pretty high hopes for the industry, Eimers says. I think there is progress being made every day, whether it's breeding around the mortality events or figuring out exactly what's happening. Colin Eimers is a PhD student at the UNC Institute of Marine Sciences, which is part of the Department of Earth, Marine, and Environmental Sciences within the UNC College of Arts and Sciences. The collaborative team of scientists behind this research include Rachel Noble at the UNC Institute of Marine Sciences, Tal Ben-Horon at NC State University's Center for Marine and Science Technology, Grant Murray at the Duke University Marine Laboratory, and Amy Wilbur at UNC Wilmington. Their funding comes from the North Carolina Collaboratory and North Carolina Sea Grant.